Hi, my name is Judi Friedman, and I'm chairperson of PACE, People's Action for Clean Energy. We're the largest all-volunteer state organization interested in clean energy. And we're very excited about all the developments that are happening in Connecticut and all over the country and all over the world, because they're an answer to a great many problems. Clean energy means energy that does not use fossil fuels or nuclear power. Our organization promotes the use of renewables, and we try to educate people about the use of renewable energy. Renewable energy being all kinds of solar technology, solar electricity, solar hot water, solar space heating, passive solar heat. Very thrilling technologies that are viable in Connecticut. We're also interested in wind. We're interested in small hydro, and we're very interested in geothermal energy as well. Our organization also embraces energy efficiency and conservation, because that's the bottom line, and that's something we can all do. And in Connecticut, we have some great opportunities. We have a Connecticut Clean Energy Fund, which I'll talk about shortly, and also a green power sign-up that anyone can do who pays an electric bill through CLNP or UI. If you sign up for the green energy option, you will be increasing the demand for clean, renewable energy. Today, I'm very excited because we have a wonderful guest with us, someone who puts his beliefs into his work. And he's a very fine gentleman. I've worked with him in the past, and he is what I would call an expert in a very exciting form of energy. It's called geothermal energy, but some people have other kinds of descriptions for it too. His name is Rick King, and he's with King Energy Associates. Hi, Rick. How are you?
Hi, Judy. How are you? Thank you for that.
You're welcome. What has your day been like today? What have you been doing today?
Well, today we did what's called a flush and purge on a 6,000-foot horizontal ground loop for a customer. It's called Camp Horizons, which is just a wonderful camp for it's weird that it just happened to be today, but it's a wonderful camp for kids that are disabled.
And where is Camp Horizons?
It's in South Wyndham.
And when you say what are you doing at Camp Horizons? What are you actually doing? I'd like you to tell the audience what is it you're doing.
Well, what we did was that the people that run this place. I was just like amazed at how much they give to these kids, okay? And they're building an 8,000 square foot building so that they can winterize their facilities, because it's a summer camp, but they want to run their programs year round.
Because people need help all year round.
Oh yeah, sure. The kids want that. And I don't blame them. And so Chris McAboe is the director, and she is a big believer in geothermal. And she's building this project that requires a winterization. Most of their cabins are not winterized. It's a summer camp.
Now, what does geothermal mean? I mean, geo makes me think of geography or geopolitical or something, world, earth, something like that. And thermal makes me think of heating. What is geothermal energy? What kind of energy is that? Is it the sun? What is it?
Geothermal, as is appropriate to the heat pumps that we install, is mostly solar energy. Excuse me, but it's solar energy that's once removed. Okay, in that the sun shines on the planet and it warms the planet. Okay, and the seasonal variation, we all know the seasons. There's a term that's used that's geo-exchange, which means that we're looking for a more stable temperature outside to extract heat in the winter and to reject heat in the summer. And the outside air temperature goes through too many extremes, where underground those extremes are more moderated. And that's really what geothermal or geoexchange.
What is the temperature of the ground when you go in the ground about?
Well, when we go with a horizontal ground loop, there's two different types. It's a horizontal or a vertical. The horizontal will go down, the ground temperature itself will go down to like 40 degrees.
Above freezing.
It's above freezing, and it's very easy for a piece of refrigeration equipment to take heat out of something that's that warm.
Okay, so you have a building, and then you have land in front of the building, and then underground you have pipes running underground. Is this what you horizontally? Is this what you're talking about?
Exactly correct.
Uh-huh.
That's exactly correct.
And what are those? What's happening in those pipes?
Well, what's happening is it's a heat transfer. Okay, that all of those pipes, whether they're horizontally laid in trenches or vertically where they're drilled, you drill a water well and put the pipes down the well. Either way, the plastic pipes are in. They're a heat exchanger in which we circulate an antifreeze solution, okay? And it's a sealed system, okay? We're not using the water in the well.
Good.
Okay, that's right. Everything is sealed, okay? So, you know, all we're doing is sending out water that's at, let's just say, 40 degrees, all right? And it comes back at 46. But the heat pumps extract some of that temperature and send it back out at 40. Okay?
And what, okay, so you've got the heat pumps and they've extracted this temperature in the winter. You want to maybe get some heat in the winter.
Yes.
And then what happens, and you can use this in a home too, right?
Oh, that's most of our business,
Most of your business is with homes.
Yes.
So this is something people could do in their homes if they want, if they're interested in this alternative energy.
Oh, they do that all the time, yeah.
So, okay, we're getting the water's at 40, and then you're taking the heat out, and then what happens?
Well, whenever you want heat to flow, okay, heat only knows warmer to colder, okay? It's just like downhill, higher to lower, okay? It's just a question of the kinetic energy, okay? If you want heat to move, heat will always move from warmer to colder, okay? So if we take...
I noticed that, my blood.
Well, it's true. It's true, but you know, if something is at 32 degrees, your initial reaction is that that's cold until you cross it with something that's at 26 degrees. Then it's colder, right? Yeah. And heat will flow from here to there. And that's basically the fundamentals of the refrigeration system that we use. The refrigerant that is in the heat pump itself will evaporate from a liquid to a gas at about 18 degrees. And when it evaporates, it absorbs a tremendous amount of heat. Just like when you sweat on your skin, that water evaporates and a lot of heat comes off you that way. In the evaporator of our heat pump, okay, refrigerant is at a low enough pressure where it will evaporate at 18 degrees, okay? So if we bring fluid through a heat exchanger from underground that's at 40 or 35 or even 32, okay, that's still warmer than the 18, and that will boil the refrigerant. Once the refrigerant boils, and now it's a gas, you can bring it to the compressor, and the compressor will increase the pressure. When you increase the pressure on a gas, you increase its pressure and temperature. So what the compressor does is pumps up the refrigerant up to a high enough pressure that it will give back those BTUs at about 100 degrees.
So what you're telling me is that a homeowner could build a house and want to heat it with geothermal energy. They could put these pipes underground. You wouldn't see them. The lawn would be covering it, or some kind of ground cover, hopefully, instead of a lawn. Right. And then in the winter, this system extracts the heat from the earth, or the heat, and helps to warm the house. Is that right?
That's absolutely correct.
And in the summer, is the reverse true?
Yeah. The only difference, and this is kind of an odd thing, and I'll just point it out to you. In the wintertime, there's something that all manufacturers say is the heat of absorption, okay? The heat of absorption means how much are we extracting from the ground, okay? And then the compressor itself is a big electric motor, and it consumes power. So the heating output of the system equals the heat of absorption plus the power consumption of the compressor. And in the summertime, there's called the heat of rejection, okay? How much heat do we dump into the yard plus the power consumption of the compressor, because that's also got to be rejected. So the machine does a lot more work in the summertime than in the wintertime, because the heating requirements or the electrical requirements of the compressor help you in the winter, and they hurt you in the summer. Mm-hmm. But on the other side of the coin, anybody who has a condenser is, July 14th, it's 95 degrees out there. Can you imagine how much easier it is to cool your house with pipes in the ground?
The ground's already cool.
It's 60 degrees down there,
Yeah.
But that's the only thing I'd like to point out, is that there is a difference.
Now, what about electric demand from the system? I mean, is this going to make, sure, you're heating with from the earth, you're getting the heat from the earth in the winter and the coolness from the earth in the summer. Is there a strong electric component so that your electric bill will go up to run these compressors?
The machines do require electricity to operate, okay? And one of the things I make sure that I tell any potential customer, you got to realize that the machines run on electricity, okay? They have rated what's called a COP, which is an acronym for coefficient of performance, okay? And it really means an efficiency. The machines that we install, they run COPs, coefficient of performance, from 4.0 to 4.6. What that means mathematically is that they're 400 to 460% efficient. Okay. Mm-hmm. Now you may think that's crazy. Okay, but
it does sound that way.
It does sound crazy. But actually what it means is that the number of BTUs that the machine consumes with electricity are augmented by the number of BTUs that it extracts from the yard, okay? And that's where it gets more than 100% efficient.
Wow.
Okay, because those BTUs are measurably extracted from the yard, mm-hmm. All right? In terms of payback, it gets very difficult. And I would like to, tell people that payback is something that is dependent on the relative cost of the fuels.
Yes.
Okay. Oil, gas, electric, they all move sometimes in lockstep, sometimes not so much in lockstep. But from an efficiency viewpoint, it's difficult to beat a geosystem. Okay.
Well, it's a wonderful idea too, because we are not using natural gas, which supply is going down, 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 and the extraction process is polluting, and oil, for which the extraction process is terrible, and we're probably engaged in a terrible, terrible war because of oil. Doesn't involve using nuclear power, which our organization is particularly concerned about, because not only the waste, but the threat of terrorism and the ongoing emissions from nuclear power and the aging plants. So that's a wonderful thing. This is a form of energy that is using the ground as the source of energy. Is that true?
It is true, and what I like the most about it is the way that it can dovetail with some of these other things that, in particular, your organization is involved in. Photovoltaics, small hydro. If we, my thought is, I'm a geothermal heat pump installer, and whether people put these in and hook them up to the grid, or whether they put in a photovoltaic system, it just seems to me that the potential is there to decentralize our whole power system. And it's great to put in photovoltaics or wind or small hydro, but how are you going to heat with it?
Yes, that's the problem.
If you can heat your house
Yeah.
with it at an efficiency of 400%, I think you get much more bang for your buck for that small hydro.
A lot of people
or for
don't
that wind.
understand when they hear the term photovoltaic solar electricity that it is not a good idea to heat with solar electricity. It's not efficient. Solar electricity is very useful for lighting and for other appliances, but for heating, it's not a good idea. So a nice marriage, I guess, is the geothermal for heating and then the solar photovoltaics to supply the electricity. Then that seems to me to be a beautiful combination.
That's what I think.
Yeah.
You still have to be hooked up to the grid, okay? And we will always be hooked up to the grid. I think that's reasonable to assume. But we will do so much better, I think, if people were more self-supporting and if the the production of the electricity wasn't so centralized.
Well,
if it was decentralized, it would be a wonderful thing.
I think that is an important point that lots of people don't understand. Right now we have these huge plants or huge sending out, and even Hydro-Quebec, thousands of miles away. We're getting power from that, and that's coming on transmission lines, and that is wasting a tremendous amount of energy just in the transmission of it.
Yeah.
So you're talking about decentralized power. That means that you're creating your power near the point of use, and that makes great sense. And also, not only does it make sense environmentally, economically, but it makes us much less vulnerable to terrorism. Because with the large centralized systems, we could be easily crippled, as we've known from rolling blackouts and things like that, by terrorism or even a malfunction of the system. So decentralization is critical, and I'm so glad you mentioned that.
I think it is true. I mean, we have had power outages that happened because of a relay that failed in Niagara Falls. And next thing you know, New York's lights go out, right? We shouldn't be so dependent on a single source.
Absolutely not.
That's what I think.
Yeah. Well, geothermal is a wonderful idea, and it seems to me the idea of using the earth as a cooling and heating place is pretty old, like animals way back who dig holes, burrows in the ground, and use the coolness of the earth in the summer and the warmth of the earth in the winter. I mean, even the cave people knew that, so it's really not such a new idea. The heat pump has transformed it, I think, to a little different level. But the idea is a very ancient one, isn't it?
No, that's absolutely true. We've been doing this since 1983, and I remember doing a home show in Hartford at the convention center, and this old timer came up to me, and I was talking to some other people, and I was talking to them about how the conductivity of frozen soil is actually higher than the conductivity of not frozen soil. Okay. And it's really true, okay? Heat goes through frost. It'll go faster than through non-frozen soil. It's a bit of a leap of faith on my part, okay? But this guy must have been like 75, 80 years old, and he said, yeah, you know, when I was doing classes in the engineering department at UConn in the 30s, we ran tests on that. You're absolutely correct.
Oh.
And I was just kind of like dumbfounded for a little bit, and it basically indicates your point is that there's really nothing new under the sun.
No, there isn't. Just better use of it and use what is natural to us, what makes sense. There's so much common sense in using the earth, I think. One thing, though, I have heard a criticism of geothermal energy in the open loop system. Can you tell me what that is and how you feel about that idea?
Well, I will definitely speak to it. Okay, this gets to business. Okay, we have always just our business philosophy at my company. We've always wanted closed loops. Okay. We wanted closed loops because we feel that once we install a closed loop, it's done. It will never. There are no variables. There's nothing that's going to interrupt how the machine operates. Open loops have actually been more of a standard with geo-exchange or geothermal systems. I wish they weren't, okay? And the reason is, if you think about it, how many of you folks have like the Culligan man come to your house? All right, the Culligan man comes and he says, you need this, you need that, you need this. There's pH problems, there's bacterial problems, there's sediment problems, there's dissolved mineral problems. All of these things are in your water. And if you used an open loop system, all of those things are running through a very intricate heat exchanger in the heat pump. Now, if you don't have any of those problems, you will be very, very happy with the operation of your unit, okay? If you have a couple of those or one of those or a severe version of those problems, you may not be happy. As a businessman, okay, I can't take a position where somebody may or may not be happy, okay? My customers are happy. That's what I do.
I've heard that.
Yeah.
That's the rumor.
Yeah, and I just can't. There are good things about open loop systems, okay? But they're so site specific that I can't trust it. And I don't know how to work it out. So we just go closed loop. That's it.
Well, also, I think, and tell me if I'm wrong, in the closed loops, open loop system, you're pulling precious groundwater out of the ground. And I know there is one institution in Connecticut that is pulling thousands of gallons of water from groundwater from the ground and sending it through the system and then into a river. And I'm in love with groundwater if it's pure. Aquifers, I think that's what sustains us. Yes. So I would not want to take any chance on diminishing an aquifer for the heating. It seems like we're defeating the environmental purpose a little. Does that make any sense? Am I right?
Makes a lot of sense. I am not a geologist, okay? But I will tell you that my thought is that, say, this guy right over here in this, 200 unit subdivision could do this, okay? If everybody, all 200 of them did, is it sustainable? I don't think so. Yeah. That's my thought. Because the water that is in that aquifer, just because you dump it back on the surface, it doesn't mean it's going to get back to that aquifer. It might have come down from Canada.
Right.
We don't know.
Hundreds of years, thousands of years ago.
Yeah, and I just think that if everybody can't do it, then I don't think you should let anybody do it.
Good reasoning.
Does that make sense?
Yeah.
Because otherwise, it's not. You can't sustain it.
Yeah.
And
we really have to think about sustainability and whatever we do, that we think what's the long-term effect on this, and not just think of me, and what I can get out of it. But many of us have children, and our children love children, and we want to think about the broader community, not only our own children, but all children, and water is so precious. Rick, sometimes people complain about the rain and the snow in Connecticut, but yeah. I tell you, when I go to beautiful sunny California and I fly over the desert and I hear about Las Vegas water problems, I bless the water we have in Connecticut, and it comes from the rain and comes from our aquifers, and we're so lucky. So protecting that water makes us, I think water is probably going to be identified as the new gold, more valuable because it is basic to human life.
It's more important than oil.
Understatement.
Basically, it
underline,
yeah,
right.
It really is.
Right.
When you get down to it, you have to have water.
Right.
Yeah.
Do you want to speak at all about your feeling about what people can do to help the earth and help us become more sustainable? Do you have some thoughts on that you'd like to share with us?
Well, I'd be happy to. Okay. I think, and this kind of diverges from what I do for a living, okay? I install geothermal heat pumps, or geo-exchange heat pumps. It's what I do for a living. And it's fun, and I like it, and I've been doing it for a long time, and I've had a lot of success with it. Before that, I used to work for an organization called ConSave, which was an energy audit operation that was run by the electric company. And there are still remnants of that program that come and go and stuff, and I just really love that program because people don't know what to do or how they can help. Okay, everybody wants to save oil. You know, I happen to be I'm not a market guy, but I do think, in my heart anyway, and people can disagree with me, that people don't save BTUs, people save dollars. And I think it's important that if you behave in a way that's inefficient, you are penalized monetarily. I believe that. Mm-hmm. On the other side of the coin, I really believe that people should have access to advice as to how to do better.
Yes.
Okay, I really believe that. I go into people's houses a couple times a week where there's 2 inches of insulation in the attic. Compact fluorescent light bulbs have been around for decades. There's no reason for anybody to have incandescent lights anymore.
Right.
You know, there's just no reason.
Yeah.
There's no excuse at this juncture.
I think that's what our organization is all about, energy efficiency and conservation. Of course, we have to remember when we do compact fluorescents that they should go in hazardous waste, but they're still a better option than mercury coming from power plants, which it's doing now.
Oh, yeah. Sometimes you have to think about which is the least evil.
Yeah.
You know what I mean?
Yeah, that's
and
right.
I think that's the way you guys are with nuclear power. Mm-hmm. It's like, you know, you don't like nuclear power. Other people think, well, it's the least evil.
Yeah.
But you know something? We can do better than
we can
do better than nukes.
We can do better than nukes. And
I know we can.
I just want to thank the listeners for listening to our program, to Nutmeg Community Television for helping us, and Rick, for your time and interest, because you put your soul into your work, and it's a very beautiful marriage to see your labor and your soul combined in such a lovely and useful way. So geothermal is something closed loop is something I really support. So I wish you lots of luck, and thank you for being on our show, and I'm sure everyone enjoyed hearing about geothermal energy and how great it is.
Thank you very much for having me.
Thank you so much.
That's great.
So take care.
You bet. Are we good? We're good?
Okay.
Thank you.
So anyway, let's talk.